Oh boy, I've got my tripod, but I don't know. I'm not liking where I'm at. I hope this works for you. I went and got my dark pen so I can draw. What I'm working on are the trucks, the all-wheel pickup trucks. And all I'm working on right now is the mechanical assembly. And the key for this is smooth operation and alignment and security and reliability in rolling. Not worried about the power pickup. I've studied that. I know how to do that. We'll do that next. But right now, I just thought I'd share with you some of the nuances, what I had to go through, what you may or may not have to go through, and how you try to get around them. The first thing that we end up doing is we take the axle, and since we want all-wheel pickup, if you have a solid axle, you can only have one wheel steel and the other wheel has to be rubber, or there'll be a direct short on the track, right? So to have two steel wheels, they must be isolated. That is, the metal wheels have to have a piece of something in between them, and I choose plastic. Let me get here's some more wheels. These are Leon's wheels, so don't get attached to these wheels because they're going to be mailed out. Okay, these are Leon's wheels. So if you're on the axle together, you have continuity. That's bad for power pickup. Got to have isolation. So we cut that axle in half. We end up with two halves. Now we've got the axle, and then we want to keep them in alignment. So we have an adapter insulator, which is a cylinder with a hole in it. Although the hole doesn't go all the way through. We can draw over here. I'm hoping you can see this good. The cylinder is like this, but the hole inside is like this. Okay, so that's the cylinder, and the axle goes in here, and there is a insulator. There's a piece of 1 millimeter, 1.5 millimeters of plastic inside here. This is that, so that when you press these axles in, they can't touch. Now, I say that, and after you always get them assembled, you put the voltmeter on that, make sure. Okay, always something that can happen. You never know. You get these printed. You print them, or someone will print them, and you get them. And so you need to check them. A couple of things I check for right off the bat. I get my calipers out, calibrate them, and make sure it's in millimeters, because that's how you start to think that way after you do this a lot. One is you want to make sure the length is in a good shape. This is a 1374. The spec on it is 1375, so we don't fuss about 0.01 millimeters, do we? Okay. The diameter I've made it is 7. It's 691. It's close enough for me. I made it 7. It was thinner. What was it before? It was 6. Now it's 7. I wanted it to be a little more robust, knowing you had the space. Why not make them a little more meaty and strong? Now the wheels, I had trouble with the wheels. Well, I had trouble with the axles because the diameter of the axles, one, we had the length, right? The links are 34, the knuckles are 37 millimeters, and the new axle from a third-party supplier is 37.8 millimeters. Way too long. Really got into the way of everything. But the other thing we have to worry about is how much space are we going to be able to have, because it's dictated by our assembly frame, pivot frame. The distance here and here is about how much the wheel can go. And so this one is 29.6 right here, 29.6. So when you're assembled and you're going to measure your assembly like this, it cannot be 29.9. It has to be less than 29.6. So these, which are just randomly picked up, 29.45. They work fine. But the challenge is we're going to be pressing these short axles in there, and we're going to be pressing the wheels onto the axle, so we end up with an assembly And that assembly cannot be over the 29 wheel to wheel. And I should have taken one of those off, but I didn't. And I don't think I have one laying around. Heck, I don't want to take it off. Too lazy. But any case, that's what you have to worry about. So the trick here is when you put this thing together, on the end you're going to have 3mm stub sticking out. You're going to have the wheel, it's going to look like this, okay? Then you're going to have another little bit of space. That's about 1mm. Then you're going to have your insulator, and this guy's got holes in it. It's got about a 1 mil in there, but it's 13.7. Then you're going to have another 1 mil there. Then you're going to have your wheel again. And then you're going to have another 3 sticking out here. Then the wheel, I think, is what, 676? I don't know, I just measured them. Measure them again, why not? Well, this one says 680, 6.8. It's fine, 6.8. So you got 6.8, 6.8, 3, 3, 1, 1, 1, 13 something in the middle. So you measure all that up. But this number here has to be 29 or less. You can be 29, maybe 0.5, but it shouldn't be much more than that. And this overall dimension has to be 36. Right, 36. Because of the 3 and 3 is 6, you get 30, and the target up here was 30. So this is how this has to go together and how it has to look. And some of the challenges I had, in addition to the axles being long, okay, so if the axle's cut in half, you cut that half and it's too long, I had to take it over there and clamp it and grind it down a little bit more until I got what I needed. I have that number somewhere, but it doesn't matter. It is. I got them all done. Then I put them together, and it was still too long. I couldn't figure out what was going on. And then I found, interesting, the particular spacer that I had selected to print had been designed a while ago, and it was inaccurate. Oh heck, I can't draw. I'm thinking about talking and not drawing. Okay, here we go. One end was 6 and the other end was 6.5, and they were different diameters, and this piece in here, at one point it was like 2.5, and another point it was 1. I was going all over the place, and what I found was one, the part had changed, or I didn't update that particular part like I should have some time ago, long time ago, and my printer has been really remodeled. Has a lot of new things put on it that makes it work very good. However, when you make changes, just like your car, if you add headers, you got to change your timing in your carburetor settings. You know what I mean? I had to go in and make some changes. The parts were printing out. They were printing out like this. A cylinder should have been like this. Yeah, it's coming out fat-legged. We call that elephant toes. See that? Looks like elephant. So it was like something here and something here. It wasn't the same, wasn't smooth. That makes you crazy too. So you realize what you have to do. You have to pick the nozzle up off the floor. This is called raising the Z. So you have to raise the Z until this thing prints flat. And I had to go through that process. Then I had to look at my temperature. I was at 225. I thought, well, maybe that's a little too hot. Other parts needed it. This one, maybe I'm going to go back to 220. So I did 220. Then I changed. I didn't change the speed. I did change the infill, because this has to be a strong part. I want it to last. I usually, on prototype pieces, really the first runs in that, I'll go 10%. I don't want a lot of plastic. I just want to know the form. But on other, as you get closer to trying it out and working it, you go to 30, you go to 50 maybe for good, most pieces. On this one, I went to 100. By golly, I want this thing so full of plastic, it will never break. And so I did all of these changes to it, but in the end, what I came out with was the spec and the design and the form that I needed for these things. And they just spin. They're so happy. I don't know if I can do that for you. You see it, but they all spin beautifully. And those are bronze inserts inside, so there's not a ball bearing, but it's bronze on a steel, and I polished the ends so they roll really, really nice. So their alignment, you can see that. Now this thing, some of these will have a little more movement than others, but what I've done is I'll put a shim, like the motor shims when you put your armatures in place. Here we go. You have these brass shims, right? They just look like a little circle. They're flat. They come in different thicknesses. We have a 0.005, 0.01, 0.02 inch. Okay, small of an inch. Anyway, I think I have 0.01s in here, and I put them between the side piece and the frame. This is a two axle 4-wheel pickup, as I built these and put these on other tenders before we got into I gotta have the big thing. I gotta have the Hemi pickup trucks, but there you can see it's a 2-wheeler. Anyway, they work all the same way. They'll have the same dimension. The dimension all comes from this piece here. I recessed the head so I had more room to do the build work. You'll see when I do the wiring, you'll see this gets a little tight on us now and again. The other thing I want to be all right with, I have a plan, but I haven't executed the plan to tie in the last wheel set. I do these 2 wheel sets because I have that design, and I know what it looks like. I can show you. I think you could see it if I do it. I do it right here. Okay. So I'm going to have a piece of wire, and it's going to coil around, and it's going to just look like that. That's all. Very simple. And looking down on it, it's going to look like this. But when you look at it from the side, it's going up. And on this piece, there are 2 holes, very small holes. There's one on this side of the pivoting area and on this side of the pivoting area, and it takes a number 2 self-tap screw, and that screw is going to go right through this center of this bent wire, and it's going to tie it down to this one. Now on the other side, since there's 2 of them, this one would be on the inside, so on the other side you'll have another one. Just don't look at this one. So you're going to have a screw here and a screw here, and you're going to have one on each side. The wire is going to run along the outside, and it's going to fit right into this 1mm groove. So that wire is going to go between the wheel and the spacer, and it's going to rub on the axle. And sometimes you get a kink in them, rubs on the wheel, that's fine too. But ideally, you just like it to rub on the axle, and you want it to go, if this was the side view, you want it to go under the axle so it actually has some tension, kind of pushing that axle up. Also, when we're driving around, the wheel hits a bump, the whole thing can pivot, and that will give it some flexibility, some suspension, I call elasticity or something. There's another word I use, I forgot it. I use it so much I forgot it. Okay, fine. So this is the assembly. This is what these guys would look like. That's just really a nice one. I haven't gone too long. I can't really see my clock up there. I'm going to take this apart just to pull one off so you really better understand the whole mess. There you go. So this is the wheel assembly. Okay. And the things we worry about, as I mentioned, is this piece out here, 3mm, 1mm gap in here, and making sure it's square and stable, and the lengths 36 end to end and less than 30 wheel to wheel on the outside, wheel to wheel. Okay, those are the key things. And when you assemble these things, you can't just hammer them, or you got to take some finesse, you got to take some time, have a cup of coffee, don't be in a hurry. Be patient. These things work, they get assembled, you'll be fine. And I know it looks like, wow, you loosen that one screw, it's just going to fall apart, and it might. when you put these wheels in, all 6 of them add rigidity to the center and it gives them alignment. But then when you tighten the screw, it ties it to this pivot truck, just like that. It won't come apart. Shouldn't. It doesn't. Other ones have. These don't. These are stiff, and I got them shimmed and stuff like that. They don't come apart. They'll work on the track. They roll like champs. See, yeah, it rolls like a champ. See that? Whoa! So and they're going to conduct. Right now, I'm getting power from these 4 wheels. Eventually, I will get power from all 6. And the power is, this is one rail, goes to one side of the transformer, there's another rail, goes to the other side. It goes up into the tender, and that gets converted AC to DC. And you know that story. I've been watching that for weeks now. Okay, so that's the mechanical assembly of the 6-wheel truck. 4-wheel truck is identical, just, you just have this much. It's only two-thirds of the problem. It's much easier. The trick is to get your wheel assemblies squared and equal and all the same, and then when you put them together, you may have to put a little shim in here to make sure these don't have so much flex they can fly apart. And early on I felt terrible. I sent one of these out to a guy, and he was having to hold it together with the rubber bands. I could not believe it. Anyway, we're beyond that. And this one will work fine. And how this mounts up. That's what I call a top hat, or it's a type of a screw. It's just a flat piece with a sticky out part and then a big hole in it. Threads are pressed into that hole, and then this side has a little screw slot. And this will go on the top side of the tender. This would go on the very top where you would have normally soldered your wiring. Don't do that with these. Anyway, it sticks down through the tender, and it's the exact same hole as the America Flyer. So I have put these on the metal-based tenders, no problem. It's all isolated, right? It will stick down. You put a shoulder screw, the short shoulder screw for couplers. I use those because they work so well. They look nice too, right? And they're not too bad, 45 cents or something like that. Yeah, if you're working on your train a little bit, you're probably going to need a few of them. So you stick that in the hole, it'll poke up, and then you tie this in, and in between it would be your tender metal or plastic, depends on where you are and what you're doing. That's how that works. Now the wire, like I was telling you, the wire, let me use this. The wire is going to sit right in here. It'll come in underneath like that and touch that. Then what you'll do, from the top you can see the wire right there coming out. You'll see it. You'll solder a little, not a little wire, it's a 22 gauge copper with flex lining. You solder a wire, pretty long wire, and then you pull that up into your tender, and you make sure you take the wire from the same side and you connect them, and you run that to your AC to DC converter. Now you've got DC coming out with all-wheel pickup, and that'll run everybody, especially the trains that we're building. That's how they operate. I can show you on the 2014 what I installed, finished. The wiring is in there. You can see it. And the screw that I told you about. Now this is 6-wheel, but it's only these two, okay? I still call it all-wheel pickup because I'm going to get to that, but what I'm going to do, I'm going to run a fixed wire from here to here. So these two will be connected always, and then the thin wire will be the pickup piece. It'll pick it up from here and here and here. Runs it up, okay? All right, that's it in a nutshell. That's what's going on. And all of these parts are on Thingiverse. This is a 2-part piece. You print the top, you print the bottom and the top, and then you line them up and you epoxy, super glue them together. I had too many features. I wasn't able to print this, so I had to just slice it and do that. These you can print. I print them straight down like that. They come out really nice. This one looks pretty good too. These are a little more difficult. I print those down flat like that. And then these guys, we print them standing up just like I told you. Just got to watch for that elephant foot. Make sure you don't have too much Z height or too little Z height. And then they come out, then you cut your axles, fit the shafts, the wheels, check your spacings, make sure that wheel assembly is exactly what it needs to be or within a few millimeters, tenths of a millimeter. Then you do your assembly and you do the check, make sure they all roll nice. Then you may want to take it back apart. It's easier then to put your wiring on. And I'll do the wiring thing on a separate piece, okay? I don't want to drag this out. All right, well, I hope that gave you some insight into the trucks, what they are, how they work. They will work on all of the tenders that I have seen. I mean, there may be something you find, oh, Dennis, it didn't fit. Well, okay, we'll work on it. Tell me what you need. Usually it's just to change the diameter of this piece or the height of it. Maybe it's too thick, too short, or whatever. Or if it's hitting something on there, that may be something I can't fix. You have to either decide whatever it's hitting, you got to cut it off or bend it or just not use these. I don't know. You have to see. The real fun part for me is to put these on the plastic tender chassis, and then, like we're doing with the Stingray, you can just do anything you want now. You can make it whatever you want it to be. Different kinds of tenders and different stuff like that. Okay. Oh, just for comparison's sake, I do have a nasty old. It's not nasty, but you know. Yeah, see that comparison if you need it or want it. It's about 5 millimeters longer. Don't know why or how that happened. The center hub is not radiused, it's square. I've just called out on that. My dots and depressions are not exactly the same as the factories, and on, okay? But the beauty of it is, what I send you, you can change it if you want to. You can design your own because you're going to have all the dimensions, okay? I don't know how that happened. It just, you know, once you're in the design mode, you're just going, you know. So that's the trucks. All right, I'm printing. Oh, I got a surprise. Not ready yet, but I'm printing ash pan modified to fit on the Atlantic. Oh, yes. I did a test, did a quick cut. We'll see if it fits. I may have to do some tweaks, but I have an engine waiting for it. We'll see how that works. So the ash pan is really coming to fruition. It's looking great. That's not the real one. I don't know where the real one is. Here's a real one in black, if you haven't seen one. This keeps the engine from being seen from underneath and clears the trailing truck. Provides your coupler mount for the tender and bolts to the DC motor frame and to the screws out at the cab. So we got that nailed. I really like it. I'm really happy with how it came out. It came out better than I was hoping it could. Always wanted to make a few changes, but not soon. So you put that in. Oh, here it is. Here's this. I did. I have Leon's DC fields for his motor in black. I like red. Everybody I know is different. He wants black. Everybody's going to get black, by the way. I just bought a whole bunch of it. So there. This will bolt on like that. It's really cool. Bolts on like that. This hangs onto your motor, so it goes in like that. And you're looking at it, and you turn your engine upside down. Turn your engine upside down, you see that. That's pretty cool. Okay, that's it. I'm a little dry now. I'm gonna go get a Coke. Okay, we'll talk later. I hope you got something out of that. I hope you see these parts. There is on Cults, C-U-L-T-S, there are some tender parts there. I don't think I've updated them, so you may want to stick with the Thingiverse right now because those are the most current. I got a new. I modified this thing in the last 4 hours, so I have the part on my PC. I have to upload it, so I'll do that before I stop for the day. So you'll have all the newer stuff on it. There's also a video on how to do the full assembly, and I guess that's all. All right, I'll shut it down and we'll talk later.